Okay, once again, good morning, folks. So we are going to go ahead and talk about sampling today. I talked about it last time, but the video got cut off, so that's why I'm going to talk about it briefly again today. So sampling. What is sampling? Okay. Sampling is the collection of data from population. You are collecting data from the population, and you remember what is the definition of sample, right? Sample is a subset of population. Sample is a subset of population. So when you're doing sampling, in essence, you're collecting data from the population, okay? And pretty much always it is gonna be a subset of the population, okay? In most cases, if the sample size population is large, if you're talking about, let's say, the population in the US, you'd probably be collecting sample data, not of 270 million people, but rather probably a much smaller number, okay? Much smaller number. Now, when you're collecting data, when you're sampling, as I said before, the most important thing you need to remember is this. Sample must represent the population. Otherwise, the study that you're doing is going to be pretty much meaningless if your sample does not represent the population. Next, different types of sampling. Okay. So I did say it here too. Okay. Different types of sampling. We are going to talk about convenience sampling, which is basically what the name says. It's giving out the answer to you or the definition to you. What it is whatever is convenient to you, whatever is readily available to you. For instance, if you are in a classroom and you want to find out the average grade point for the students of your college, the students who happen to be in your class, you take data from them, collect their GPAs and find the average. That could be a convenience sampling. You are sampling whatever is convenient or readily available to you, or you might be at the cafeteria having lunch with hundreds of students, which doesn't happen with COVID-19 now, okay? And hopefully someday we will see again all the students on campus. I miss all those students, everybody being on campus and lively and happy. But hopefully someday we'll be back after COVID-19. And anyway, so if you happen to be on the campus at the cafeteria having lunch, and you want to find out some information about the student body or students at your school, and you collect data from people in the cafeteria who are available to you readily. It could be sometimes good sampling, but not necessarily always. So remember that. So convenience sampling, that's what it is. And systematic sampling, what it is, you create some sort of order, okay? You create some sort of order or system so that you can organize the entities that are concerned, okay? Organize the items in a certain way. And then you select data at a certain interval. You select data at a certain interval. For example, let's say we take the students in our class, okay? Organize everybody by their last names, okay? By last names. And then collect data from every fifth person. So let's say 5th, 10th, 15th, 20th, and so on and so forth, okay? So this would be one rule. But you can, if you're dealing with numbers, you can organize the numbers in increasing or ascending order, right? Increasing or ascending order, you can organize them in that way, right? But then you could collect data every 10th or every 5th or every other data, whatever is convenient for you or whatever makes sense for you. So that's the systematic sampling, okay? Now, stratified sampling, and the example that I try to use most of the times is zip code. So let's say this is your favorite city, which is Salinas, and these are the zip codes, okay? Now these are different zip codes. Now in stratified sampling, you divide or stratify the population into groups or subgroups. Then you collect data randomly from each of these groups. That's the example of stratified sampling. So I took the city of Salinas. So let's say this is Salinas. Of course, this is not the map of Salinas, right? And then these are the individual zip codes. 1, 2, 3, 4, 5. There are 5 zip codes. And then you randomly, let's say, select 100 people from each of these zip codes. So that would be an example of stratified sampling. That directly leads to clustering or cluster sampling. Again, you create groups or subgroups with certain rule, and then you randomly select one group, okay, and collect data from that group, okay? You randomly select one group and collect data from all of them in that group. Let me just clarify. I think it is you collect data from all subject in each of these randomly selected groups, okay? Okay, I think there is a little bit of zipper. Okay, I wonder if there is a typo here. Collect data, okay. We'll collect data from all of the subject in these selected regions. So I'll have to, I'm in the middle of the class, so there might be a little bit of typo here. I'm gonna fix it if it is there. But in clustering, you collect data from a group, from all of them. So you randomly select, let's say, zip code 3, and then you collect data. So that's what this one is. Okay, so back again, in the clustering example, I thought for a second that there was a typo. There isn't. So you divide, as I said, you divide based on certain rule, and then you randomly select 1 or 2 groups and collect data from each of these. So let's say I select this one, I select this one, and I'll collect data from each of these items in here and here. So clustering, the difference between clustering and stratified sampling is that, remember, in stratified sampling, you create subgroups and you collect data randomly from each of these subgroups, versus in clustering, you collect data from only part of these groups, so not all of these groups, okay? You may take one group in the smallest case and collect data from all entities or items in that group or all objects in that group. Or you can take 2 or 3 groups and study all of them, okay? Now, voluntary response sampling, this is basically what kind of response you get when you ask people to respond to something that you have done, okay? You ask people to respond. One great example is, let's say over the years, I taught, let's say 2,000 students, and I send a survey to them, okay? I send a survey to them, asking them to fill out the survey and, you know, tell me how am I as a teacher, how much they have enjoyed or not liked my class and whatnot. And then I get a response back from, let's say, 50 of the students, or let's make it nice number, 100 students. And out of 100, I get 90 people saying, hey, great, Mr. Hussain, I enjoyed your class, I loved it. Then I go out and say to you guys, hey, 90% of the students love my class. And do you remember from last time's discussion what's wrong with it? What is the problem with voluntary sampling? Yes.
The sample
yes.
doesn't represent the entire population.
Why so?
Because not all 2,000 students responded.
True, yet not all 2,000 students responded. That is true, but that may, well, then my population is 2,000 in that case, so I cannot expect 2,000 students to respond. Even amongst 2,000, if 100 responded, that could be a good sample, randomly selected sample. But there is another reason why this is not the, yes.
Chances are that the students that responded were students that had like a positive experience.
Exactly. Their opinion might be biased, okay? Meaning that students who took the time to respond might be the ones who really had positive experience. So in my class, so as a result, I have a very high, okay, sort of success rate in terms of opinion, right? On the other hand, in the online, so by the way, keep in mind, folks, there is no hard and fast rule, okay? This is human behavior, okay? This is sort of like random event in a way. You cannot apply one particular rule. Then on the other end, I have seen in the online, surveys, online, comments, many people tend to have negative opinion about things, even though nowadays, even to go to a restaurant, we kind of look at the online reviews, right? So many people would say a lot of negative things. I have seen that. Of course, many people also say good things, and many people give objective opinion. So you have to learn how to, discriminate between all these opinions. And discriminate, I'm using the word not in the social context, but rather in the context of being able to differentiate among all sorts of different opinions, okay? All right, voluntary sampling, it could be biased. Or another example I gave you, I'm a product seller and I give you a $5 Starbucks coupon and say, hey, would you please give me an opinion on my product? And what's gonna happen? Just because I gave you the incentive of $5 coupon, what happened is that their opinion is gonna be biased, more likely to be positive than negative, okay? Any question, guys, before I move on?
No.
Okay,
No.
good.
No.
All right, next, simple random sampling. That's the best kind of sampling you can do. In a simple random sampling, there is no restriction, no rule, except that everything has to be random, completely, absolutely random, okay? In a simple random sampling, everything has to be random, absolutely. There is no bias or no prejudice in selecting any individual items. So in simple random sampling, again, keep in mind, is done in a completely randomized way. So that means no bias or no nothing. You completely randomly select items. So one good example could be, let's say, I want to create a simple random sampling from your class. And there are, let's say, 50 students in the class. So I assign each student a number 1, 2, 3, all the way up to 50. And then I randomly create a random number using the random generator in a computer program, okay? And then select 5 students, okay? And the computer generates randomly 5 numbers from 1 through 50. The great example is the lottery tickets, right? So the lottery tickets lottery tickets, by the way, when you select a number, let's say you select a number from 1 through 50, you take they actually take 50 cubes, small cubes with numbers label on them, right? And they randomly kind of rotate it and then select numbers. That's how that's how simple randoming works, absolutely without any bias or anything. And this is the kind of sampling you'd want to do in most cases, simple random sampling, if possible, or we can get as close to it as possible, simple random sampling, okay? Okay, so let's move on to the next topic. Oh, okay. So we're going to talk about designing experiment, okay? Designing experiments here. Okay. One of the things, as I said before, when you're designing experiments, it's very important to consider SRS, meaning simple random sampling, okay? To ensure that the sample represents the population, okay? And also I mentioned here, in reality, it's not so easy to do all the times, okay? There are times you'll find that it is difficult to do completely simple random sampling. You may not have enough available subjects because it could be geographical restrictions or it could be financial restrictions. So there are many issues that come into real world when you are actually designing an experiment. You probably hear about the experiments nowadays a lot in the news and media because of COVID-19, right? Okay, they're coming up with different vaccines for COVID-19, and they're doing experiments with this new vaccine that they're coming up with. What they're doing, they're randomly selecting people and giving them these new vaccines and seeing or observing the outcomes. Okay, so this is in essence an experiment. What is an experiment? Of course, it is a controlled study. Okay, it's a controlled study. So you create some sort of controlled environment, and in that controlled environment, you probably give the subject some sort of external stimulus, and then you study their behavior, okay, or their outcome. Now I made it sound very much like very academic. In essence, what it means is this: when we are finding people with COVID-19 and giving them vaccines, that's what it means. So that's a controlled environment, and external stimulus is the vaccine that they're receiving, okay? So sometimes when you say the simple things in academic terms, it sounds very formal and very difficult. At times it could be. So think of experiment as a situation where you give somebody something and then you observe what happens, okay? It could be as simple as giving a little kid a toy and see how he or she behaves, okay? That's an experiment too, and you guys do it all the time. You give certain toys. So as a toy manufacturer, you might be interested in the popularity of the design, different designs you have. So what you will be doing, you will take different groups of kids and give them different types of toys and see which ones they enjoy the most. That's an experiment, by the way, which ones they like the most. So it doesn't have to be so formal, and it doesn't have to be so academic or medical science type of things. It could be something simple. So always when you're learning something new, try to relate it with something you're very familiar with, very comfortable with. That way you will remember it and you'll understand it much better. So we are going to talk about a couple of things: observational studies and experiments. Okay, so experiment, we kind of already talked about it. So you take your subjects and give them something, right? Externally. We call it external stimulus, and you observe their behavior or outcome. So that's an experiment. Now, observational study. In an observational study, you basically study the subjects as they are. You do not really change anything, okay? In observational study, as the name says, you just observe them or you collect data from them as they are. You do not do anything else. Like compared to experiments, think of you have 10 kids, okay? And another group of 10 kids, okay? You give each a toy in this group and observe their behavior, how happy are they, or how sad, or what kind of reactions they have. And on the other hand, this could be that there are 10 kids, you don't give them anything, you just observe their behavior, okay? Now, this one is an experiment because in essence, what you have done, you have given them some external stimulus. Now you can compare these two groups, okay? If you want to. What is their behavior like? What is their behavior like? What is their joy level like? What is their joy level like? How happy they are or how happy they are, whatever your interest is. So experiment versus study. One time I was at a campus, it was kind of funny. Somebody was doing an experiment. Some girl came up to me and said, would you like to have $5? I'm like, really? Why? Then she gave me $5 bills. Okay, actually she gave me actual dollar bills, $5 bills. Then of course she mentioned to me beforehand, it's an experiment we are doing. No, I think she mentioned about it afterwards, not before. So she gave me $5, and then she asked me to give her back or give someone else back certain amount, or how much would I give back. I just got $5 out of nothing, and then she asked me to give it back to her or somebody else. How much of it would I give back? And then afterwards, she told me that it was an experiment that she was doing for her psych class. It's quite interesting. So anyway, in observational study, you do not do anything to the subjects or items under consideration. You just collect data. Okay, you observe them and collect data.
Professor,
okay, yes, please.
did you give her back any of the money?
I think I did. I don't remember how much I gave her back. I think I gave 2 or 3. I forgot.
You went half.
Yeah, I went half. And I think she told me so far the numbers she had, I think many people gave half back. And there are some people who didn't give back a single dollar. So it was kind of an interesting experiment. Oh, one thing here. By the way, these class notes that I'm giving you, you may want to read them. Not once, multiple times. And then you will get a better sense of what the topics are being discussed, and also you'll understand the topics. So you have these class notes. I would recommend that you read it beforehand, okay? You read it at least once. If you can do it a couple of times, that'd be good. And you don't have to read it thoroughly. Just read it, browse it quickly, 15 minutes, 20 minutes, half an hour. Right before the class, if you spend 15 minutes to half an hour browsing through the notes, class notes that I give you, you'll get so much more out of the class. Trust me on that. As a student, sometimes I did it, but most of the times I didn't, I admit. But just spend 15 minutes to half an hour right before the class, going over the class notes, the topics that I'm going to be talking about. You don't have to understand everything. Just go over those, and then you will get the class, the discussion that I have in the class much more, and you will get much more out of the class. So one of the things is So subjects or the units are not given any external treatments, but are observed or studied in their natural setting or context. Again, it sounds very academic. What you are doing is basically you are not disturbing them. Okay, if there are five cars, in a parking lot, you just collect data on 5 cars. So you are not doing anything to them. If there are 5 people chatting and talking, conversing, you just collect data from them. You are not doing anything to them. You take their natural setting and then collect data or observe or study them. So that's observational study. Now there is something called retrospective study. Okay, retrospective study, which is basically you go back in time. Okay, you go back in time and you collect data. That's retrospective. And one very good example I found out online is this. Over 50 years ago, from a period of 1900 to 1950, many of the nurses who died from lung cancer were smokers. Okay, or what percentage of the population? Okay, that's a different example. So back from 1900 to 1950s, okay, over the 50-year period time, many of the nurses, they were dying of lung cancers, but one habit or behavior that they all had in common, they were smokers. Okay, very interesting. So what you did, you go back in time and you collected data. That would be an example of a retrospective study. Or another example could be you go back in time and look at people from Hiroshima and Nagasaki. Okay, Hiroshima and Nagasaki, let's say you collect data from people who survived the disaster, atomic disaster that has happened to Hiroshima and Nagasaki, and you study their life, let's say from 1945, okay, that's when it happened, to let's say people who survived up until 1950, okay, or whatever time period is of your interest, okay, you study, or it could be from 1945 in theory up to now, okay, you study them. So that kind of would be like looking back in time over a window of time, okay? You are collecting data and you are observing and analyzing your subjects. Cross-sectional study is kind of like you are doing things, observing or collecting data on the, oh, okay. Sorry, this is just an example. At a single time point, okay? You are collecting or observing your subjects at a certain cross-section or certain point in time, okay? So if we collect data about the college students who graduated in the year 2020, which is a very difficult year for everybody, for all of the world, it's a very difficult year. We can collect data on the people who graduated from college and what percentage were able to get jobs after graduation, where millions of people are losing jobs. All right. So this could be an example of collecting data from a single point in time. Okay. So my unit of time is 2020 here. Okay. So you collect data at a single point in time. So prospective study. In prospective study, the subjects are observed or studied over a period of time that goes from present to the future. So you start studying a group of subjects and you study them from now on, let's say, further out in the future. And I think one of the great studies was done in Boston, if I'm not mistaken. They took a lot of people, I don't know, maybe 20,000 people. I don't know the exact number, but a pretty large number of people. And they observed their food and diet, okay? Food, diet, and exercise, okay? They observed their food, diet, and exercise habit over a period of time, and they observed the things like how many of them develop diabetes, or how many of them have heart attack, or some other disease, could be cancer or whatever it may be. So this would be an example of a prospective study where you take certain group of people or a sample from your population and you study them over an extended period of time and observe some outcomes. And this big study, I don't know if it's called Boston study, but I forgot the name, but they have done a long-term study on a large number of people, and there are some great results that came out of that study. And it all relates to health and well-being and different types of disease and people's lifestyle and food and diet. So that's something wonderful to do. Now, cohort study, that's kind of a very sort of semi-unique way of doing things, studying a group. Nursing program is a great example of a cohort study, or medical program, doctors, okay? People, those who are trying to be medical doctors, they are a great example of cohort study. It's a group of people, okay? It's a group of people that go through the exact same routine work over a period of time. Like as a nursing student, if you are in a entering nursing class, let's say the students that have entered the nursing program in the fall of 2020, okay, fall 2020, this group are going to be taking the exact same classes over the next 2 years, okay, because it's a very rigorous program. Everybody has to take the same course. And I see them working very hard and very religiously, and they spend a lot of time studying together. This group, cohorts, this group is called a cohort group. They go through the same experience, okay, over a period of time, then you study them. The same for doctors, by the way. Doctors also go through the same experience, okay? They take the same courses, do the same labs, work at the same lab with the same type of patients, okay? And they go through this experience. So you study this group, that's called cohort study. Any question on this cohort study, anybody? Everybody okay?
Yes, thank you.
So these are to summarize, we have talked about a few of these things. So let me just write them here for you. So we talked about observational study, study. Number 2, we talked about retrospective study. Number 3, we talked about cross-sectional study. And number 4, we talked about cohort study. So these are the 4 things, and you may want to make sure that you understand the differences among them, okay? Observational study, to summarize, you observe them in their natural setting and collect data. In any kind of study, by the way, you observe them in their natural setting and you collect data. So it could be observing them at present time, or it could be going back in time and observing them. That means collecting data. Like a good example is the nurses who smoked a lot, okay? And then a cross-sectional study, you study your subjects at a certain point in time, like in 2020, the graduates, college graduates, you know, you collect data about their employment rate. Yeah, so it's one point in time. Cohort study, a group of people go through the same experience in a lockstep. So maybe I haven't used that word. In the statistics world, they love to use this expression for cohort study. They do things in a lockstep, okay? They go through the same experience over a period of time all together, okay? Like the nursing or the medical students taking the exact same classes all together over a period of 2 years or 4 years, and go through the same lab experiments or experience as well together over 2 or 4 year period. So that's what it is. Here is a kind of, I share this story with my students sometimes. It's kind of funny, but true. I was talking about smoking, right? From 1900 to 1950, many women who were nurses died, but they were also smokers. Back many years ago, when I came to the US, it was very surprising. I don't know if I told you guys, I'm from Bangladesh. I grew up in Bangladesh. I went to high school, up to high school there, and then I came here to the US for college. Okay. So now, when I came here, I lived in a dorm, college dorm, and it was very surprising to see that I used to go to school in Michigan, by the way. It was very surprising to see that women, younger women, smoked. Okay. You know, we are 18, 19-year-old, and I saw younger women smoking. That was a big news to me. Back in our culture, women don't smoke. I have never seen a single woman smoking. Even to this date, I heard some women smoke, but they don't do it in public. But when growing up, it was kind of funny. When I was a kid, only person I have seen ever smoked was my grandmother, and it was considered very unusual. So she used to smoke, and I was like, wow. Now I look back and I think, wow, it was kind of cool, even though it's not healthy. But it was very surprising for me to see younger women smoke. But in California, thank God, we are so environmentally conscious and we are so careful. Our regulations are so good. I hardly see people in California smoking outside. On the other hand, when I lived in Boston area, Massachusetts, I saw people smoking everywhere. And in California, that doesn't happen. So here is my little story about smoking. Okay, so we are done with this experiment. We talked about what is an experimental study. Main thing is that you give the subject some external stimulus, and you get, after providing them the external stimulus, you study them or you collect data from them. All right. Now, once again, just to remind you, now we are going through a crisis, which is COVID-19. California is in a bit of a trouble right now. COVID-19 vaccines. So you're giving vaccine to certain patients or certain type of people. So what you're doing an experiment on them. The external stimulus that we are talking about, it would be the vaccine. What is your outcome gonna be? Whether their condition improves, or are they immune to, do they develop immunity to COVID-19? So all of these things are kind of like described here. So let me just explain different terms that you will be hearing. If you read a research report or if you read a newspaper, you might see or come along these terms, and I want you to be comfortable with this. Experimental study, versus observation, Now, experimental entities, these are the items or individuals or things that are being experimented on. So in case of COVID-19, people, those who are receiving the vaccines, they would be the experimental entities, okay? In case of a production line, an item that is being produced, that could be an experimental entity. So depending on what context and what circumstance you're dealing with, your experimental entities could be different. In case of COVID-19 vaccines, it's humans. In case of electric car, it could be an electric car, or experimental entities could be the batteries you are talking about, right? In case of something else, it could be something completely different, and it all depends on your experiment. So experimental entities are things or items that are being studied. Then response or outcome. So is the characteristic or thing that is measured on the experimental entities. So again, example helps you understand things. If you look at COVID-19 vaccines right now, okay, now that, by the way, is gonna be, after a person receives it, whether the person develops immune system or not, that's gonna be the response or outcome, okay? After you receive the vaccine, you either develop an immune system that protects you against COVID-19 or not. So that's the outcome. Speaking of COVID-19, many people are getting COVID-19 vaccines right now. Most of them, I hear, they're going good, and hopefully it does. My mom is gonna go through it tomorrow. Hopefully everything is gonna be okay. Prayers for her. Next, treatment. Treatment is the external stimulus that you're giving. In case of, again, COVID-19 is the vaccine, okay, that you are receiving. Or in case of electric cars, if you're talking about the batteries, it could be the new chemicals or new things that they put into the battery that's supposed to extend the battery life or store the charges better. So it depends what the treatment is. In different cases, it could be different thing. If somebody gives you $5, that could be the stimulus or treatment that you're receiving, okay? Randomized study, okay? Again, it's basically saying that you are randomly studying. So you'll hear randomized study. A study or experiment in which experimental entities are given certain treatment at random without any bias. So when you are giving the COVID-19 vaccine that some corporation, Pfizer or AstraZeneca or Oxford came up with, they give it randomly to people. They don't select very specific type of people, okay? One of the things that I have been hearing about the COVID-19 vaccines that they are giving, it works for certain people, but maybe it's not sure whether it works for people who are under 16 or people who are pregnant, okay? Or people who have underlying health conditions. There are many, many things. So you could do a sub-study on COVID-19 vaccine on pregnant women or children under 16 or people with underlying disease. So there is going to be a lot of study being done on this COVID-19. It has shaken the world in a way that we haven't seen in our lifetime. Nobody living, unless they are like 118 years old, that or something like that, they probably remember 1918 Spanish flu. That's the last time when such a major catastrophe has happened to the humanity. Hopefully we come out of this thing of COVID-19 peacefully, and we don't want to see any more lives lost. Okay, next, randomized study. So random study, blinding. So that's a very important thing you'll be hearing, blinding. In an experimental study, blinding used when study subjects do not know whether they are receiving the treatment or placebo, some generic thing or with no effect. So here is a very interesting thing. Again, I'm going to use COVID-19 example. So there are 100 people that are receiving that COVID-19 vaccine. Okay, it's kind of funny, but it is true. If you receive a medication that's supposed to cure something or alleviate certain things, get rid of certain diseases, it has a psychological impact. What it means is that, let's say you gave 50 of these people COVID-19 vaccine, and the other 50 received something called placebo. Okay, it turns out that they don't know. Okay, these people don't know. So 50 actually receives the vaccine, 50 do not receive anything. They receive placebo, but they are thinking, they don't know that they are not receiving the vaccine. So they're thinking that they're receiving the vaccine. Now they study both of these groups. Of course, if the vaccine is effective, a higher percentage of people, a much higher percentage of people would be what? Developing immune system compared to this group, right? But interestingly, you might find some people from here actually getting better or improving their situation. That's the interesting part. And it is psychological. This is probably not a good example because it's a vaccine, so you can test whether the immune system has been developed or not. But for some other medication, some other disease, so they take a medication and they're supposed to improve. They take the placebo, they are not supposed to improve, but some of them actually improve their condition. Okay, so to avoid these kind of biases, what they do is called blinding. Oh, sorry, blinding, this one. Then we'll talk about double blinding too. Blinding is a scenario where the subjects do not know whether they're receiving a placebo versus an actual medication. So this could be COVID-19 vaccine. We could use it for something like this. We take 100 patients who actually have COVID-19 and give 50 of them the vaccine, okay, and see how they react versus 50 of them, you give them placebo and see how they react. Okay, so that could be an example because we know all of them have COVID-19. Now you see how much they recover in this out of this 50 and how many recover from this 50. So that could be a comparative study, and you can see whether the vaccine you have developed is effective. So this is called blinding, where the subjects do not know, right? Where the subjects do not know whether they're receiving the stimulus or some placebo. Now, the double blinding is another scenario where, interestingly, what happens is this. The person who is conducting the experiment might be biased too. If the person knows that these 50 people received the medication, these 50 people did not receive, then when the person collecting the data might be biased in a way to think that, oh, they received the medication, so they might be improving their condition, whereas they did not, so they may not improve the condition. So to avoid the experimenter's bias, okay, we use something called double blinding. In double blinding, not only the subjects not know what they're receiving, but also the experimenter doesn't know what subjects are receiving what, whether they're receiving a placebo or the treatment. So in double blinding, not only the subjects, but also the experimenter not know who is receiving what, who is receiving the stimulus versus who is not, who is receiving the placebo versus who is receiving the actual treatment. So that's double blinding. So now hopefully when you read journals, medical journals or any medical report, you would be able to understand what is blinding, what is double blinding, what is randomized study, what is a treatment, or what is experimental entities, things like this. You should be able to very easily identify experimental entities, okay? Experimental study versus observational study, okay? All these things you should be comfortable with. So let me summarize what I did talk about. We talked about experimental study, where you give your subject some external stimulus and you observe the response or the outcome. Entities, experimental entities are things or objects or items that are under consideration that are receiving the stimulus, okay? Response or outcome, as the name says, the result that you see. Treatment is the actual stimulus that you're giving, and randomized study is basically ensuring that you are providing these treatments in a random manner. Blinding is a situation where the subjects do not know what they're receiving, whether they're receiving the placebo or whether they're receiving that treatment. That's a single blinding. Sometimes it is also called single blinding. And the other one is called double blinding. In that case, not only the subjects, but also the researcher or experimenter does not know which subjects are receiving treatment and which are receiving the placebo. Okay. So confounding, I found defining the confounding is a bit confounding, honestly. Sometimes it could lead to something not so clear. Okay, so confounding, or also known as confounding variable, is something that hides the true reason for an outcome. Confounding variable is a variable that hides the true reason for an outcome. Easiest way to give example is this. Back in the time when people didn't know what causes lung cancer, okay? So this is a great example, and I want you to remember this. Back in the time, people didn't know, long time ago, what is a cause for lung cancer, or what is the rather leading cause for lung cancer, okay? I should not say just cause. Leading cause for lung cancer, people didn't know. Now, at that time, they observed these two things. One is smoking. They noticed that people who developed lung cancer, they smoked. And also, they noticed that people who develop lung cancer, they also drank. So they have smoking habit and drinking habit. And what is the outcome? You can think of this as stimulus, right? Or cause, I guess. And this is your outcome, lung cancer. So in a very broad sense, many people who are developing lung cancer, they tend to have these two things common. So they didn't know for sure which one was the leading cause for lung cancer. Is it smoking or is it drinking? Now, fast forward time, and we know that lung cancer, leading cause of lung cancer is smoking, not so much drinking. So this drinking is the confounding variable. Why? It confounds or confuses the cause for true outcome. Now in real world, there are many situations where you are dealing with confounding variables, okay? There are multiple potential reasons, but leading to one outcome, and you don't know which one is the leading cause, okay? Which one is the leading cause? So one good example I could give you, a student named John Doe is doing very good in the class, getting an A in school, okay? So outcome is that this student is very good. Now, one potential reason could be the student studies a lot, very smart. I hate to use the word smart, honestly. We are all smart. It's just that we don't use our smartness, and if you don't use it, then you become not so smart. And over time, you yourself start to believe you are not smart, and then the society, of course, believe before that. Anyway, so student is smart. Or it could be the case that the student comes from a well-to-do family with lots of financial resources, and he gets good opportunities for learning. That means gets good tutoring or good study materials and resources that are needed. So now, is the student smart, or is it because the tools that are being provided to him or her. It could be one or the other, or it could be a combination of things. So it's hard to distinguish leading cause. Okay, so there are variables that kind of confuses or confounds the leading reason for an outcome. So lung cancer, this might not be a great example, but this is definitely a great example. I like it. Okay, so I hope that it makes sense to you. So confounding variable is a variable that kind of skirts the that kind of confounds or confuses what the true or leading cause for something. Now there could be multiple confounding variables as well. So anyhow, so is it okay? Are you guys comfortable with it? Any question, anybody?
I'm okay, thank you. I'm okay.
Okay. All right. What time is it? 9:45. Is it time to take a break? 9:45. Yeah. Okay. So we'll take a little break here. Now we are going to talk about some of the basic definitions in statistics, and you may know some of it as well. So mean or average. Okay, mean or average. We will interchange these words, average and mean. Okay, what is mean? Mean is defined as, basically, in layman's term, you add the numbers and what? Divide by the total number of data points. That's what it means. So if I ask you to find the average for -2, 3, -2, 3, and 5, what are you going to do? You're going to add these numbers, right? -2 plus 3 plus 5, and divide it by the total number of data points, 3, 1, 2, and 3. That's going to be 6/3, which is 2. So the average of these numbers, these three numbers, is 2. Now, this same concept, by the way, is expressed right here, but in terms of symbol. Instead of actual numbers, if we say our data points are, let's say, x1, x2, x3, and xn, these are your data points, okay? Then it is gonna be, the average is gonna be x1 plus x2 plus ... plus xn, all of it divided by the total number of points. How many data points are here? N of them, because it starts from one subscript. So this is called subscript. Subscript. Okay, x sub 1, x sub 2, x sub 3, all the way up to x sub n. Okay, so you add up all these data points and you divide by the total number. How many total numbers? In symbol is n data points. That's exactly what I have here. Now in statistics, sometimes we try to write things in a compact way. Okay, the n in the bottom is just a one symbol. No problem, we write it. But on the top, you have sum of all these individual data points. So this is an individual data point, this is an individual data point, and so on and so forth. This one is an individual data point. There is a compact way of writing it. It's written like this. Summation I, this is read summation. I is equal to 1 to n x sub I. This and this are the exact same expression. And this is, by the way, is the definition of mean, and mean is denoted by x bar. That's also another symbol that we use. Mean is denoted by x bar, as you can see here. Now, at first, if you see, you might be thinking, oh my God, it looks complicated formula. All right. No, it is not so complicated. Okay. It is not so complicated. It is pretty straightforward, and you can do it easily. So now, hopefully this symbol is not confusing you. So instead of writing x1 plus x2 plus all the way up to xn, there is a shorthand notation that we invented. This is sigma, like S, the Greek letter sigma. Okay, it's uppercase S, I guess. Sigma I goes from 1 to n. That means I goes from 1 to n means I is 1, 2, 3, 4, all the way up to n. X sub I. I goes from 1 to n summation xi. And that's what it is. So x1 plus x2 plus all the way up to xn. All right. So this is the notation. So x bar is defined as x1 plus dot 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 plus xn divided by n, which is also summation I is equal to 1 to n x sub I, okay, all of it divided by n. And the symbol for it, symbol for mean or average is x bar. It is something important for you to remember, and you will be using it a lot. When we say average x bar, it means sample mean. That means if you have a population, from the population you collect a sample, a subset of the population, and you find that mean, it is called sample mean. Sample mean is denoted by x bar. So in parentheses, let me put that. Right here, I'm gonna say another thing, very important. There is also population mean. It is denoted by the Greek letter mu. Okay, and there is a distinction between these two. Population mean is the average of all the items that are in the population, whereas sample mean is the average of the sample that you have collected. In reality, you do not know what the population mean is. What is the average age for the people who attend college in this country, okay? You don't know that number. In theory, you could ask 10 million or so, I don't know how many millions. Let's say we have 10 million students in college. In theory, we could go ahead and ask all these students individually, one by one, how old they are, and add those numbers and divide it by 10 million, that would be mu in theory. But you don't have the human resources as well as financial resources to do that calculation. So what do? We collect a sample from this 10 million and find that average. From that sample average, we try to estimate the population average. So from sample mean or sample mean slash average, we try to get population or approximate population mean slash average. And that is pretty much a good portion of statistics. In this example, what I explained you in simple terms is what you will be doing in statistics. You don't know what is the population parameter mu is. Now, you may remember from the first day of classes, we talked about parameter. Parameter relates to some property of the population, and statistic relate to some property of the sample. So in all of statistics, you are kind of collecting data from a sample, and using that data, you come up with some sample statistic, and from that you try to estimate to the best of your knowledge the population parameter. First, from sample average, you try to get population average. From sample standard deviation, you try to get population standard deviation. or sample proportion or percentage, you try to get population proportion or percentage. So this is exactly what happens. And this is very important for statistics. From sample, we go to the population. That means from sample properties, we estimate the population properties. Enough of this. So please know these two symbols. I'm going to be asking you, X bar and mu. X bar is the sample mean, mu is the population mean. And our objective is to go from sample to population property. Next, we're going to talk about something called weighted mean. And this is important for you to understand because couple of reasons. Most immediate impact is how your grade is calculated. In this class, I use weighted mean to calculate your grade. On the very first day of classes, I may have given this example. If a student, John Doe, okay, got the following scores in homework, he got 80 out of 100, okay, homework. And then midterm, he got 90 out of 100. Final, let's say, he got 70 out of 100. What is his or her grade, or what is John Doe's grade? Now, many students, they take these three numbers, add them and divide them by 3. That's like finding this average. That is telling you, you have 3 categories. Each category is 33%, 33.3%, okay? 33.3%, 33.3%. When you are adding and dividing it by 3, you are in essence giving the equal weight to each of these categories. But in reality, homework might be 20%, okay? Your midterm might be 30%, and your final might be 50%. Then if you do this, that means add these numbers up and get the average that is not true reflection of your grade. Now, how would that be? So let's do it here. Homework, you got 80 out of 100, and homework is 20% of your grade. Then your midterm, you got 90 out of 100, and that is 30% of your grade. And your final, you got 70 out of 100, and that is 50% of your grade. To find your average, which you would call weighted average, you take this number and multiply it by the corresponding weight. So it's going to be 80 times 20% is 0.2, which is going to give you 16. All right. 80 times 0.2, which is 16. Now, similarly, midterm, you got 90, but midterm is 30%. So 90 times 0.3, which is 27. Final exam, 70. But it is 50% of your grade, so you multiply it by 0.5, which is 35. Now, if you're going to add these numbers, so what do we get? 6 plus 7, 13 plus 5 is 18. 8, carry over 1, 4, 6, 7, 78. So it's kind of like overall, you got 78% or 78 out of 100. Technically, there is something else here. To find the weighted average, I just did the top, okay? Multiply the corresponding weight by the corresponding data point. So corresponding weight for homework is 20%. Corresponding data for John Doe is 80 points. However, you have to divide the entire result. So that means this result by sum of the weights. Sum of the weights. So 20% plus 30% is 50%. Plus 50% is 100%. But sum of the weights is 100%. which is just 1, right? Isn't it? Let me take this notation. 100% is 1. So 78 divided by 1 is still 78. So you really don't see it. However, there is an interesting scenario. It will change things. What if I do the following? Final exam, instead of 50%, I made it, I don't know, 40%. Then things are going to change. Then look, this 40 plus 30 is 70 plus 20 is 90. It does not add up to 100%. And it really does not have to add up to 100%. But most of the times we do that way because we are more comfortable with 100%. In this particular case, see, it adds up to 90%. So in that case, you have to divide it by 90% or 0.9. So let's go ahead and do the problem. So I'm gonna, let me just write it out here. That way it will be easier. Homework 80, which is 20%. Midterm 90, which is 30%. And final 70, which is 40%. Now, these two multiplied together, 80 times 0.2 is 16. Then 90 times 0.3 is 27. Then 70 times 0.4 is 28. Now, if I add all of this, I'm getting summation Wi xi. That's the numerator of it. I'm getting summation Wi xi. And it gives me 7 plus 6, 13 plus 8 is 21. So it's going to be 1, right? K over 2. 2 plus 2 plus 2, 6 plus 1 is 7. So you're getting 71 here. Sum of the weights times the individual data points. However, to find the weighted mean, you have to do summation xi wi divided by summation wi. Now remember, summation xi wi is 71, okay? Now you have to divide by sum of the weights. Now sum of the weights is 90% or 0.9. If it is 100%, if these numbers add up to 100%, you don't have a problem. But if it does add up to 90%, then you actually have to divide it by 0.9. So you divide it by 0.9. And if you did that, by the way, it's going to be 71 divided by 0.9, which is x bar is equal to 78.88% roughly. That's how you do it. So make sure when you're doing the problems, make sure that you are doing it properly. You are adding it, you're multiplying and then adding it to get the numerator and then divide it by the sum of the weights. If it is 100%, then you won't see any difference. But if it is anything other than 100%, you will see a difference. I could have changed it from 40% to, I don't know, maybe 70%. That don't make a difference. So let's go ahead and do it again in another way. Homework, you got 80 out of 100, let's say, and it is 20% of your grade. Midterm, you got 90 out of 100 and it's 30% of your grade. And final, you got 70 and let's say is 70% of your grade. I just made it up. Now, if we do the math, it is gonna be 80 times 0.2, which is 16. 90 times 0.3, it is 27. 70 times 0.7, It is 49. Now you add them up, you're going to get summation xi wi. That means you're getting the numerator, remember. So 13 plus 9 is 22, 2 carry over. Okay, 8 plus 1 is 9. So your numerator x bar is equal to summation xi wi divided by summation wi. Now this numerator is, by the way, 92. That's what we got right here. However, what is the denominator? Remember, if these numbers were to add up to 100%, which is just 1, then you divide this by 1. 92 divided by 1 is fine. This is what you are more used to. But the rule doesn't say that it has to add up to 100%. It could add up to any percent. In this case, what it is, 20 plus 30 is 50, plus 70 is 120%. Okay, 120%. 120% is 1.2, by the way. So you'll be dividing it by 1.2. So your x bar is going to be 92 divided by 1.2, which is 76.66%. So you're getting roughly about 76.66%. This should be 76.66. So let me just take up this, okay, which is out of 100, so 76.66%. Is it okay, everybody? Are you feeling comfortable with this weighted mean definition?
Yes, I got it.
Yes.
Yes.
Yes,
So,
thank you.
thank you. Make sure that you get that, sorry, not that one. You get this one, that means the top, and then you get the bottom as well. Okay, and that's when you will get. Now, here is a great example. This one you can do on your own, all right? However, this one, let me do it myself. So you're taking 4 courses this semester and you get the following grades. English, you get A, stats, you get A, history, you get B, and psych, you get C. Remember, the units for each course is what? 3 unit, 5 unit, 3 unit, and 4 units. So let me label these grades. A means you're getting 4 for English. For stats, you got 4 as well. For history, you get 3. For psych, you get 2. Okay. I'm gonna just raise it, write it here so that I have more space. 4, 4, 3, and 2. And these are your grades, and the units are 3 units, 5 units, 3 units, and 4 units. Now, this is an important point in our discussion in terms of weighted mean. Figuring out which one is your XI, which one is your WI. XI is the actual data points. That means the score that one receives. WI is the weight. That means how much that data point worth in the total. How much that data point is worth in the total. Now, look, here is the scenario. These are your grades. These are your units. Now, I want you to help me out and tell me which one is your weight, WI, which ones are your grades, XI. It's important. Otherwise, you will get the answer wrong.
Your grades XI are the actual grade you got from the class, like 4, 4, 3, and 2. And the weight is the units.
Exactly. Thank you, Alicia. This is your XI. This is your WI. Okay. One point here before I go any further. You guys know that this class is being recorded and I'm putting it on YouTube, so that is in public. So when I call your name, does anybody have any objection calling your name? Because if somebody else watches the video on YouTube who might not be even in your class, then your name will be there. Are you guys okay with it, or anybody has any concern?
I'm fine
Yes,
with it.
that's
Yes,
fine.
fine.
That's fine. Okay, I just want
That's
to make
fine.
sure. All right, so I don't think really many people would watch it because it's an hour and a half long lecture, or 2 hour long lecture. I don't think there are people who are out there sit down and watch it. But anyway, I just wanted to make sure that your privacy is honored. So you're welcome. One good thing, a good way to remember is that weights, they never change. Like the percentages, homework is 20%, let's say, right? Different students can get different scores in homework, but for all the students, homework will always be what? 20%. Will that ever change? For this particular class, that will never change, right?
No.
In exactly the same way, the English class, different people can get different grades, A, B, C, D, and F, but these 3 units will never change. For all the students that are taking this English class, their unit would be fixed, which is at 3. The things that are fixed, that are always gonna be your W's or WIs. Things that can change, which is the grades in this case, it can change depending on what different students get. Those are your XIs. Now, this is an easy way to remember this. Weights always stay fixed. On the other hand, the grades or other thing, whatever you're dealing with, will change or vary. So now, after clarifying this, let's find the product Xi, Wi. So 3 times 4 is 12. So that is this. 4 times 5 is 20. That is this. 3 times 3 is 9. 4 times 2 is 8. Now, if I add these numbers, I get my summation Xi, Wi. That means I get the numerator. Remember, my formula is X bar is equal to summation Xi, Wi divided by summation Wi. Technically, there is a thing here, I goes from 1 to n and I goes from 1 to n. Well, sometimes we skip it when it is clear what we are talking about. In this case, I is going to go from 1 through 4 because there are 4 data points. Now, so 32, 12 plus 10 is 20 is 32, plus 9 is 41, plus 8 is 49. So the numerator is going to be 49. Now you have to find the sum of the weights as well. So summation Wi's, okay? That's going to be 3 plus 5 plus 3 is 11 plus 4 is 15. So your sum of the W's are 15, are some of the weights. So 49 divided by 15 is going to give you 3.266. 3.266 or 267 repeating, so let's make it 3.27, and that should be your GPA for the semester. And that's how they calculate your grades, by the way. Grade point average is a weighted mean. Is this clear to everybody?
Yes.
Yes, thank you.
Yes.
Okay, great. Okay, so let's move on to the next topic. So for this, I'm gonna just start it up, and we are gonna talk about bar chart first. And this is where I will actually give you some programming experience. I'm gonna write some code, very simple codes, and then you're gonna go ahead and just basically type in that code and play around with it and come up with different kinds of pretty looking pictures. Okay, and it's very easy, it's not too hard. And before I get started, let me go ahead and talk about a little bit. Everybody has a Gmail account, right?
Yes.
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 Okay. Now everybody has Hartnell Gmail account, so you should be using this. So you will need to go to Google Drive, drive.google.com. Okay. .com. Once you get there, you have to use your Hartnell Gmail and log in. Or you don't even have to do that if you are already logged into your Gmail account. Let's say you're on a browser, you're logged into your Hartnell Gmail, okay? If you're logged in, then if you type in drive.google.com, okay, you'll be able to go there. And I think I'm gonna share this file with everybody. I'm gonna write this and I'm gonna share it with you, and then when you go to your drive.google.com, you will see that file. Make sure that you're logged into this. If you're not logged into Gmail, it will ask you for user ID and password for Hartnell Gmail, and you'll be able to do it. And also, when I share it, they're gonna send you a link too. Okay, Google is gonna send you a link that will basically take you to the Google Drive. Now, for this one, I will make a short video and I'll show you in the video how to create these things. Google, you guys use it for search engine, but they are doing some exciting work and some very creative work in education. One of the things that I think very powerful what they are doing is this. There is a Python. There is a Python programming language, okay? Python notebook. You can use it on a Google browser. So if you have, you can use it on other browser too, but use Google Chrome, okay? Pretty much everybody nowadays have access to Google Chrome, and a good portion or good percentage of people use Google Chrome. It will work on any browser, but Google Chrome is the recommended one. Then maybe Safari if you're on a Mac, okay? Even if you're on a Mac, download Google Chrome, okay? And then run it there. And it's a browser-based programming, and it's so easy, and it's so much fun. Honestly, it is fun, and it's free. Google letting you use their computing, okay? They're letting you use their computing power for you guys so that you can learn and educate yourself. And that is a wonderful thing to do. Okay, what they're doing is wonderful. They're making it for free for anybody who wants to learn. So we are going to be using that platform, and I'll create a video for that, and you'll find it relatively easy. So bar chart, what it is, think of different categories. So bar chart goes with categorical data or nominal. Bar chart is something that goes with nominal data. Now look, I draw a line. This is Salinas, so that's where my Salinas is, Monterey is, it doesn't have to be in that order. Marina is, Seaside is, Pebble Beach is, and Gilroy is here. So Salinas has 10 gyms, okay? So there are a number of different gyms, cities in Monterey County. Gilroy is not in Monterey County though. It is in Santa Cruz County, Santa Clara County. But anyway, that's not much important for us. So here they have 10 gyms. So that represents the height of 10 gyms. So that's your Salinas. And then you give a little space, and Monterey has 3 of them. And be consistent when you are giving these spaces, right? So that's Monterey. And then Marina has 2. Okay, Marina. Then Seaside has 3. So we're gonna make the height. Let's call it Seaside. And then Pebble Beach has 2. So let's make it 2 PB. And finally, Gilroy has 5. So there's 5 Gilroy. All right. So that's what a bar chart is. Okay. There is a difference between bar chart and the next thing, or one of the next things that we will be talking about is histogram. There is a difference between bar chart and histogram. And histogram goes for numerical data, quantitative data. Bar chart relates to categorical or nominal data. In this case, if you reorder the things, it really doesn't matter. Okay, you could put Salinas at the end and Gilroy at the beginning or in any other order. It just gives you a visual presentation of the data. It just says what it is like, okay? So that's what it is. So now let's go ahead and
We only have this bread.
let's go ahead and talk about other things. So next Pareto chart, I will talk about it later because this thing somehow got out of order. The easiest thing next to talk about would be the pie chart, as the name implies. Okay, pie chart. So let's use this space here. Pie is kind of like the pie too. All right. You take certain collection of data, typically in groups you can think of, right? So you assign part of the pie proportionate to the data. So let's say you have a data set with 100 data points, okay? 30 of them in certain category, 20 of them in another category, 10 of them in another category, and 40 of them in another category. So 30% of the data is one category, 20% of the data in another category, 10% of the data in another category, and 40% of the data is another category. All of these, by the way, should add up to 100%. Let me make sure. This is not weighted mean. It has to add up to 100%. So typically the rule is this: you start here, okay, and you draw a line here from, this is your baseline you can think of. You can start anywhere in theory, but it really doesn't matter. So let's say you start here and go there. So data type 1, okay, let's call it D1, D2, these are individual labels, okay, D3 and D4. So you give 30% of the pie. So let's say this is the 30% of the pie in D1 category. And 20% of the pie, my 30% didn't really, sorry, let me just make it a bit more realistic. 30% is gonna be somewhere here, okay, D1. And then you give 20%, the remaining to D2. So this is your D1, D2, and then you give 10% to D3, and the rest is 40%, which is to D4. Okay, these are the things. Now this sounds very abstract. So this is how pies look like, and they use different colors to visually enhance it. So maybe they would use red for this. Maybe they would use green for this. Now you can see it comes to life. They may use black for this, and they may use yellow for this. See, when you actually put colors, it comes to life. It's more easily visible. It's more easily visible. And by the way, in reality, you will never ever do these things by hand. What you're gonna do, you're gonna use some sort of programming language, some sort of statistical software to create these things. And in our case, we're gonna be using Python. I'm gonna write a small code for you so that you can do Python coding, and it is gonna create all of these things for you. By the way, I do strongly encourage that all of you learn Python, basics of Python. You must have some sort of knowledge of programming language in today's world. Programming is extremely powerful and useful. Everything you touch in your life, somehow directly or indirectly, has some sort of programming associated with it. Okay. For example, you can think of self-driving car, right? You don't care about programming, but you care about self-driving car. That's fun, and that's gonna create a huge economy. Interestingly, to design self-driving car, behind the scene, you're doing programming like crazy. You're doing statistics, you're taking data and using programming to analyze that data and then come up with conclusions. Remember, I gave you an example. Data, then you have some program in the middle and you come up with conclusion whether it's a human or not a human, right? If you're driving, you should be able to figure out whether there is a human being in front of you or an object in front of you or not. So it's very, very powerful programming. Many students nowadays who go to school, high school, they know programming, and you guys should pick up programming. So I'll get you started with this Python programming. That is, by the way, the most universal programming language that for ordinary people is extremely powerful. It's professional as well as for ordinary people. Professionals are using this programming language and ordinary people are using this programming language because it's easy to learn. Maybe I'll give you a class project if your time permits towards the end of the semester, where you'll be doing your own project using the Python programming language. Even as simple as writing a program to do weighted mean, what we just talked about. Okay? The weighted mean calculation that we just talked about, you can write a program to do this. And when the schools and colleges are doing calculations for your grades, do you think that there is a human being sitting down there and doing the calculations? Probably not. It's a program that automatically does it. If there is any human being working behind it, that would be me. At the end of the semester, hopefully I'll give you a good grade, and I record it on pause, and they take it from pause and they probably run it through some program, and that gives you the final GPA for the semester. So far, you have learned two things. One is bar chart, okay? Or sometimes they might say bar graph. So these terms are really, to be proper, you should be using chart. So bar chart, okay? What happened to my pen? So bar chart that relates to nominal data or categorical data. And then pie chart is another way of presenting data that uses visual appeal, like a pie. You divide a pie. If you really want, you could call it a pizza chart too. It's the same meaning, because pie and pizza, they are similar shape, and you could divide it accordingly. Now, the next thing is stem and plot, which is another way of displaying data. So this is visual. All of these things we are talking about is visual. So descriptive statistics. Remember, we talked about descriptive statistics. This is descriptive statistics. And the other one was what? Inferential statistics. Towards the beginning of the semester, we will be talking about mostly descriptive statistics. Towards the middle or the end of the semester, we'll be talking about inferential statistics. That's what it is. Okay, I think we are almost on time. So for next class, if you'd like, I kind of want you to just, I haven't given much on this, just look at it, okay? Browse through it, but start looking at this, measures of center, okay? Start looking at that section. And the previous section, I will be doing it class, and you'll be able to pick it up from there. And then you will be doing some Python programming that will help you. To really get a feel for it, you have to do the programming, then you'll understand how it works. Okay, so that's what it is. That's all for today. And please look at measures of center and next few pages, okay, including definition, distribution of data, bell shape, empirical rule. Just browse through it. I'm trying to go slowly so that you don't get overwhelmed with information at the beginning of the semester and get frustrated, okay? All right, so that's all. Thank you so very much. You guys have a wonderful day, and we will be talking to you next class, which is on Wednesday.
I have a question.